What determines whether you and I recycle correctly or not? Whether we recycle at all, or compost, or reuse, or decide to buy something environmentally friendly, or decide to buy something at all? These questions are important. If we want to have a livable planet for a long time to come, we have to get on top of how we consume and manage our resources. Resource exploitation without limits will have to come to an end. Understanding waste behaviors will be one key to shifting towards a sustainable consumption model. So where do we start? Well, researchers have tried to answer these questions coming from all sorts of domains like economics, consumer psychology, environmental sciences, and engineering. Most of the research has focused on recycling participation, and those studies have focused on two categories of factors: environmental and psychological. So what do we mean by those? Well, each can be broken down into several subcategories. Environmental factors for recycling include, most obviously, waste bin infrastructure. Your likeliness to recycle and success in sorting may depend on whether you have easy access to a recycling bin, the number of categories to sort between, the size of the bins, and how full they tend to be, their cleanliness, and the clarity of the labels. Relatedly, environmental factors can also include education campaigns, which can include in-person efforts, print medium, and digital campaigns. They can also include higher level factors like policies that lead to waste bin deployments, or policies that lead to incentives or penalties for recycling properly or not. What are the psychological factors? Well, these are the factors that determine how we react to our environment. The more difficult it is to recycle, the more we have to be motivated to recycle. That requires understanding why recycling might be useful, which means understanding the risks and harmful impacts of not recycling, unnecessary resource extraction, pollution, and landfill impact. We also need to believe that recycling is actually going to lead to a useful outcome. We're also influenced by social psychological factors like who we live with and associate with, our sense of morality, and our understanding of social norms, what we expect others expect from us. And of course, if you already have a recycling habit, then that is going to take precedence over a lot of these other psychological factors. And by the way, this is not a new area of research. Recycling behavior has been investigated since at least the 70s. So each factor plays a role, but researchers have struggled to understand the exact or even relative contribution of each factor. That's because there are so many potential confounding factors. So the question is there a way to actually understand and model this complexity? The answer is yes, sort of. Agent-based modeling, or ABM, is a computational method to model complex systems. Systems with many components interacting with each other that often lead to complex behaviors. In ABM, agents represent individuals or groups in an environment. These agents are given rules, which are often simple, that determine how they interact with the environment and each other. ABM can trace its origins to the 1940s with the concept of the von Neumann universal constructor, an exploration of the question of whether machines could replicate automatically like biological organisms. To test this idea, von Neumann had to invent the concept of the cellular automaton, in which a grid holds cells which can take multiple states, and which update their state along time steps according to what kind of cells neighbor them. This idea later found renewed interest in the 70s with Conway's Game of Life, a computational simulation where cells are in one of two states, alive or dead. They evolve on a grid according to the count of neighbors, simulating the stress of under- and overpopulation and ideal conditions for reproduction. The results are fascinating, repeating or chaotic patterns observed over iterations of the game. By the 90s, computational power was sufficient to be able to run more complex games or simulations. These were useful to scientists who wanted to use them to understand how complexity evolves from simple rules in nature. Take, for example, the behavior of ants. We can use ABM to watch how ants react to pheromone trails while foraging for food, and how the use of different types of pheromones, attractive or repellent, can affect the foraging success. ABMs have come a long way, and they have a huge variety in their implementations. The environments can be as simple as a grid, or a map, a 3D environment, or even an abstract representation of a social network. The number of agents and the number of types of agents and environmental elements can also vary greatly. These are limited by computational power, and that has come a long way since the dawn of ABM simulations. But before we say any more about the power of ABMs and the limits of ABMs, let's look at a few specific implementations of ABMs for waste behaviors. This model simulates Chinese households and their choice of recycling at a nearby central recycling bin, having recycling collected at their door or simply landfilling. The model uses a psychological framework for behavior called the theory of planned behavior. The model is calibrated based on a social experiment conducted in Hongfuyan in China, after which several simulations of interventions are modeled. On the visualization, you can see 3 distinct regions of the city, of which the top left represents the university district that begins with the most participation in recycling, represented with the green cells. As the model runs, the recycling behavior either spreads or stagnates, depending on the weight of environmental attitudes, how important social norms are, and the weight of perceived behavioral control. This model again simulates household waste recycling behavior based on the theory of planned behavior in Kaohsiung City, Taiwan. This model adds a new coefficient, the perceived moral obligation of the household. We can see a ring of the positive recycling behavior, those yellow cells, forming in proximity to the recycling container, which demonstrates the balance between convenience factors and more social and moral factors. These models are not sophisticated enough to use as predictive simulations, but they do help to reveal interesting patterns and trends. Researchers have a lot of power in their hands these days, but they still have to decide on the limits of their models. We can't perfectly model reality. The point is to discover which factors have a bigger influence on the outcomes in the model, to include those, and decide which ones are less important. What's needed is to validate a model to see if we've honed in on the right elements. We can do this by comparing our model results to existing real-world data, or even better, to set up our own experiments. What would this look like for recycling? Well, we'd need to set up a way of controlling the predetermining factors and measuring the results. For psychological factors, there's no way that we know of to directly extract what's really going on in people's minds, but we can survey individuals about their understanding, their concerns, their perceived abilities, and their faith in what we call the efficacy of recycling, i.e., does recycling actually work? Surveying has its limits. People tend to want to look better than they really are, but it's still a useful tool. Also, we need to know about and control for infrastructure and policy factors. For infrastructure, this means understanding how many bins, their location, and of what type are in the area of study, ensuring a sufficient proportion are monitored. For policy, you need to know whether there are any incentive or disincentive schemes established. Finally, we'd actually have to measure the results. How much waste ended up in each different recycling bin? And if you really wanted to do it right, you'd also have to see whether what's in the bin is what's actually supposed to be in the bin. This is an extensive process that would be tough to do on a very large scale. But there are new technologies making it possible to do this kind of controlled experimenting on a larger scale for the very first time. Over the last 10 years, we've seen a boom in Internet of Things or IoT technology, allowing us to place small sensors inside waste bins, which can track the weight and the fill level of waste in the bins. And now, thanks to AI and computer vision models, we have the potential to even track the type of materials being disposed, using microcomputers and small cameras. This means we can understand not only how much waste is going in what bin, but whether it is actually the right type of materials. With this wireless tech, we can do what used to be done sporadically through expensive manual sorting and weighing, what we call waste auditing. We can do it continuously and for a fraction of the cost. With agent-based models, Internet of Things, and artificial intelligence, we could be on the cusp of truly understanding what it takes to get people to recycle and to do it well. And who knows, we could apply the same technologies to even reducing our consumption. Thanks for watching. If you want to understand more about waste, technology, and sustainability, make sure to follow me for more.